Hello friends, this is Jim with Science Talk, and this video segment is actually going to be talking a little bit about some potential good news. Now, this involves plastic, and you say, what's good about plastic? When you hear this report, you might be somewhat encouraged. Now, I've done stories where I've discussed the issue of plastic pollution, microplastic pollution, the Pacific garbage patch, even the Arctic waters that we're seeing microplastics there. So I've done video segments of that. I've discussed plastic in animal guts, whales, etc. You can go check out those videos in my library here. So what I want to discuss with you is basically this new synthetic plastic that's being made. Food could stay safe and hygienic, wrapped in a safe plastic made entirely from farm waste. The wrapper could then rot away without harming wildlife. So basically what they're saying is that safe plastic is not an impossible reality. So, some U.S. chemists have basically taken natural waste and turning it into natural polymers. Natural polymer. The polymers in plastic are synthetic, and they're not natural. Synthetic, right? And they persist. They don't rot. So basically, you could be packing, if this can prove to be done on a large scale, you might be able to pack your lunches in some sort of transparent packaging that could be fashioned from crushed crab shells, even discarded wood chippings. And then, because that's all compounds that occur in nature, naturally, will then be able to break down in the environment. The protective wrapping would have all the strength of polyethylene-based packaging that is typically found today. There's one big difference. It will decompose naturally. Polyethylene is the most common form of plastic, and it doesn't break down. Now, global demand of plastic is expected to reach almost 100 million tons in the near future. Plastic polymer compounds are products of the petroleum industry. And, I gotta mention this, one of the biggest users of plastic products is the medical industry, the medical profession. Right? You have a IV bag. There's a tube from the IV bag that goes into the vein in your hand or arm, wherever they insert it. There's a valve that controls the flow of whatever's in the IV bag. It might be dextrose, it could be saline, whatever. They're all made out of plastic. The only thing that's not made out of plastic is the needle itself. Everything else is pretty much plastic. That's just an example. The medical industry, and the wrapping and so on, they're a big, huge user of plastic products. So, we know that the plastics are persistent, they don't break down. So researchers are looking to see, can we address this? Can we make a plastic that will break down? And there seems to be some promise on it. So, there have been some researchers who basically said, yeah, long after humans are extinct, you're going to find a geological stratum that has plastic in it. So any future alien that lands on the planet with 7 legs, I just said that, and they drill down, things say rock, sandstone, and go, what is this? And you hit a layer of plastic. And then they continue down back to sandstone and schist and shale and so on. Okay. And now, the plastic detritus that's that we're constantly discarding is really already threatening the planet's ecosystem, right? We know about the Great Pacific Garbage Patch. We know about microplastics, all these problems all over the place. So this latest study, of using products to make the plastic from natural products is described in the American Chemical Society's journal, ACS Sustainable Chemistry and Engineering. So, how they create this. Researchers sprayed layers of the natural polymer chitin. Now, chitin is basically what makes up insect exoskeletons, okay? As well as the crayfish or a lobster, that kind of, right? As well as the plant polymer cellulose. Cellulose is what makes up the cell wall of plant cells. So they made basically thin, flexible, transparent material that could hopefully one day replace PET or polyethylene. Polyethylene terephthalate. That's the actual name. Cellulose is by far the most common natural polymer. It gets into very long chains. And chitin might be the second most common. But when it comes to cellulose, you could say that it literally does grow on trees. Sorry, couldn't resist. Okay. But chitin is made by the is the carapace of exoskeleton of various invertebrates. Now, in addition to cellulose, there's also lignin, and lignin is basically what makes a woody plant a wood. That it's a type of cellulose, but it's a long chain polymer, and it what gives strength to woody plants, your trees, your shrubs, those kind of plants. But what they do is they alternate the layers, and basically getting down to the nano level. And so there's a group of scientists that work in scales of billionth of a meter called nanotechnologists. A nanometer is 10 to the minus 9 of a meter. In other words, there are 1 billion nanometers in a meter. Okay? Just, if you get a meter stick, you have 100 centimeters to a meter. Each centimeter, there's 10 millimeters. Well, so there are 1,000, 10 times 100 is 1,000, so 1,000 millimeters in a meter. Well, there are 1,000 microns, micrometers, that make up a millimeter. 1,000 times 1,000 is a million. There are 1,000 nanometers that make up a micrometer. 1,000 times 1,000 times 1,000. So now we're up to a billion. So hence a billion nanometers make up a meter. This is what's great about the metric system. It's all powers of 10. Easy to play with. Now, I said this is promise. It's a long way from commercial applications. Well, we know the application. It's a long way from being available commercially on a large scale. So there's more that needs to be done. It's being tested, and there are hurdles to overcome, but it is promising. So Carson Meredith of Georgia Institute of Technology, School of Chemical and Biomolecular Engineering states, we've been looking at cellulose nanocrystals for several years and exploring ways to improve those for use in lightweight composites as well as food packaging. Because of the huge market opportunity for renewable and compostable packaging and how important food packaging overall is going to be as population continues to grow. Our material showed up a 67% reduction in oxygen permeability over some forms of PET, which means could in theory keep food fresher longer, right? If you keep the oxygen out there, then you can't get the the microbes using the oxygen to start eating away. Doing a little experiment in microbiology. So anyway, I wanted to at least share that there is some promise, because plastic pollution is a big problem. And even if they're not able to replace the polyethylene terephthalate that's used in the medical profession, just think of how much food is wrapped in plastic. buy a thing of meat from the grocery store, wrapped in, right, cellophane, right? It's wrapped in a type of plastic. Your cups, your straws, right? All these things. If we can replace that with the material that will break down and it's totally made, totally organic, this is a big step forward, and I certainly welcome this development. So, and I do hope that they're able to make this commercially on a large scale. Thank you for your time. Hey folks, this is Jim here reminding you to subscribe to this channel, to share my videos, tell others of the work that I do here. I also ask that if you are not already a patron at Patreon, to please consider becoming a patron at Patreon. You can find the information in the description box below the video. I'm asking you to help support the work that I do. I do not take any money from corporations or from any other sources, so the information I share with you is the actual science as it comes out of the peer-reviewed journals. So there is no BS, there's no propaganda, there's no agenda. It's just I present the science and I explain to you what it means, or at least my interpretations of it, based on my own experience as a scientist. I want this channel to grow. I consider, while I discuss many different topics here, you notice I do focus a lot on climate issues. I consider climate change to be the most pressing issue facing humanity today. Thus, I consider it important to disseminate this information to a wider and wider, more and more people. And I need your help to do this. So, yes, please subscribe. Please tell others of the work that I do here. Please share my videos on social media platforms, with your social media groups, what have you. We need to get this information out there. So for those of you who are supporting me on Patreon, I thank you greatly for your support and continued support. It does mean a lot to me. So together we can get this information to more and more people. Thank you. Thank you for your support.